Yo, 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 yo. Hello, everyone. It's Mr. G coming at you live from KDMS. Here we go. So, we're going to talk about 2.4 parallel and perpendicular lines. Here are your definitions. Now, what we're really focusing on is writing the equation of lines that are parallel or lines that are perpendicular to one another. And this really has to do with their slopes. So, two lines that are parallel are lines that never touch, right? They're lines that are going in the exact same direction. Well, if we know what we know about slope, slope is the steepness of a line. Well, if these two lines are parallel, they have the exact same steepness. So they're just as steep. Their rise and their run are identical. Because to get from here to here is going to be the exact same distance to get from here to here. So therefore, two lines that are parallel, they have the exact same slope. So parallel lines always have the same slope every single time. Now, perpendicular lines, a perpendicular line is two lines that cross at a right angle. There are two lines that cross at a right angle. So if I look at these two lines, one of them's positive, that's a positive slope. One of them's negative. They are crossing and they make a right angle when they cross. Well, whenever two lines are perpendicular, their slopes are going to be opposite reciprocals. So what that means is a reciprocal is when we flip the fraction. So if I had 1/2, the reciprocal would be then 2 over 1. We're just flipping it around. Well, if perpendicular lines are opposite reciprocals, that means that if the slope is 1/2 and it's positive, that means a line that's perpendicular to it will have a slope that's negative 2. Because negative 2 is the opposite, because it's positive, so now it's negative. And then 2 is the reciprocal of 1/2 because 1 over 2 is flipped is 2 over 1. So perpendicular line slopes are opposite reciprocals. Now note that none of these have anything to do with the y-intercept. So when we are talking about parallel and perpendicular lines, it is only referring to the slope. The y-intercept doesn't change anything. It just really shifts the line up and down the y-axis, but it doesn't change the slopes in any way, shape, or form. Okay, so let's look at this. So the equation, types of problems that you're going to have are, what is the equation of the line in slope-intercept form that passes through this point and is parallel to this line? So whenever we write the equation of a line, we always need to know the slope and we need to know the y-intercept. Okay? Or we just need a slope and a point and then we can find the y-intercept from there. Well, I am given a point. Here's my point. I am given the slope because I am told that the line, I want to know the equation of a line that goes through this point and is parallel to this line. Well, the slope of this line is 3/4. So a line that's parallel also has to have a slope of 3/4. So there's my slope and there's my point. Now I can write my equation by either using point slope form, that would work. Because I know it says to write in slope-intercept form, but remember, point-slope form is really just a way to get the slope-intercept form, because I can always add 9 to both sides. Oh, I don't know why it does that. It's bothersome. Okay. And that's x minus 8 plus 9. And then I can distribute. So that's 3/4 x. Let's see, that's over 1. So that becomes 1, that becomes 2, so it's -6 plus 9. So then I would just combine my like terms and I get 3/4 x plus 3. So this line right here and this line right here are parallel because they have the exact same slope. This one has a y-intercept of -2 and this one has a y-intercept of +3, which is why this one is able to go through this point over here. Okay, now you might have to write the equation of a line that is perpendicular to another one. So same idea, I have a point here, and then I'm given the slope of this line, and I want to write the equation of a line that passes through this point and is perpendicular to this line. Well, the slope of this line is -14, so to find one that's perpendicular, it would be the opposite reciprocal. Well, -14 is 14 over 1, so the opposite reciprocal is +1 over 14. So there's my slope. So now I have the point, I have a slope, And now I can write the equation of the line. This one lets you slope-intercept form, okay, to find my y-intercept. So my y is 7, my m is 1/14, my x is 1, and now I can figure out my slope, my y-intercept. So I have 1/14 times 1. Oh, that's simple. That's just 1/14 plus b is equal to 7. So I subtract 1/14, and I'm left with 6 13/14, just to make my math simple. And yes, you can just leave that as a mixed number for the purposes of this. So my final equation is y equals 1/14x plus 6 13/14. And I'm done. So again, I have my point on that line. I just need to figure out what the slope is, and I figure out the slope is by the word perpendicular, which means it's the opposite reciprocal of this slope. Now, you might be asked to determine, are they parallel, perpendicular, or neither, because it's either one or the other. Okay, well, the only way we do that is we just need to compare the slopes. There should be an x here, guys. I apologize. There should be an x there. So that should be -3/4x. That was a typo. Okay. I'll throw it right there. Okay. So I need to figure out what's the slope of this line. So what I'm going to do is I'm going to subtract 3y from both sides. That goes away. Don't do that. Terrible advice, Gradius. I wasn't thinking clearly. I apologize. Do not subtract 3y from both sides. Okay, I need to get y by itself, so I need to divide it by 3. I need to divide by 3. And I need to divide everything by 3 to write the line in slope-intercept form. However, I don't really need to worry about my y-intercept because it's irrelevant for the question. I just need to know the slope, which is -4/3 x. Now I get to look at my two slopes. I have a slope of -3/4. I have a slope of -4/3. These are neither parallel nor are they perpendicular. Yes, these are reciprocals. 3/4 and 4/3 are reciprocals, but it's not the opposite. This one's negative. This one's also negative. So therefore, they can't be perpendicular because they have to be opposites. So the answer is just neither. These are just two normal lines that are going to cross each other somewhere on a coordinate plane. Finally, you're going to have some word problems with this. Okay, what we're going to have to do is write an equation in point slope form or in slope intercept form. We might have to deal with parallel and perpendicular lines. Okay, but so we see here, this is on a grid. Okay, this is on a grid. So we're going to have to find our points from this. I can't make just the picture bigger, unfortunately. Find our points from here, and then we're going to answer the question. So try it out on your own and see how you do. So pause it if you haven't done so. Now, the more I think about this one, the more I want you guys to actually do this one as an independent practice. So even if you haven't tried it, now you have to. I did pick out 2 perfect points for you because I know it might be hard for you to see on your paper. So this perfect point right here is at 5, 3. And then this one on the east path is at 10-4. So for your east path, those are your perfect points. The fountain here is at 15-2. And then your picnic is at 5-6. So answer, I want 2 equations. One equation for the picnic path, one equation for the fountain path. You have all the information you need and go from there. See how you do. And then we're going to skip this one for right now. Things to remember: parallel lines, have the same slope. So parallel lines have the same slope. Perpendicular, opposite reciprocal. So perpendicular would be 1/2, would be -2. Or you could do another example. Okay, so 2 independent practice problems. This one and this one right here. We'll actually do this one as a warm-up in class together. So, and that's that, you guys. So I want to keep this video nice and short for you. So if you have any questions, let me know. And that's all I got for you. Gordias out.